the other nucleophilic substitution reaction, and I'm not going to tell you what it is. Let's take a look at it. It will make more logical if we don't categorize at this point. So we just draw sp3 carbon, and bromine is attached, the leaving group, delta minus, and delta plus is the carbon electrophile. So this is going to go in a reaction with the transition state. So the transition state is marked with this square bracket and with the double dagger sign like that. You can also write transition state. I call it TS. Now, we also have a nucleophile, which is I minus iodide, and it's a strong nucleophile. So when it is strong, it's going to start reacting. It's going to try to hit that way. It cannot, because I minus is negative, Br delta negative. They hit each other. So it cannot hit from the normal front. What's the remedy? It's going to go from the back. So that is called the back attack or backside attack. So this is important because there's space for a bigger I minus nucleophile to go in. You push forward and break the other sigma bond, which is carbon to Br. So like I said, substitution is breaking bonds and making sigma bonds. Breaking sigma, making sigma, right? So the Br is breaking carbon to sigma bond, and I is coming in making the sigma bond. So that's the most important thing to see. This is happening simultaneously, and we call it concerted reactions. So just copy the other stuff as it is, and now we have it. So that's why it's a transition state, the TS. And the TS also I call the monster at the hilltop, and it's hypothetical. We are imagining, it's not real, and we're going to see that in a graph, right? Okay. Now, so we can look at the product, and let's draw the product. What happens because we hit from the back side or back attack, it's kind of going to push up the R1H and also the other the bent carbon, right? It's sp3 carbon, so it's going to be pushed or flipped. It's also called the umbrella flip. I'll put the picture down below later. So it's kind of pushed up from the iodine because it's the back attack, right? Now, so what happened here, this is your product, only one product, and also you can see it's only one step, right? So the sp3 carbon, if this one is R stereochemistry, I did not figure it out, I just put the value, and then this one should be S stereo configuration. Just know that way. If you start with R, you end with S. If you start with S, you're going to end with R. So it's an inversion. So in this type of reaction, because of the back attack, the inversion of the stereochemistry is 100% guaranteed, right? This inversion also called the Walden inversion because the scientist who described that is Walden. Sometimes we call Walden inversion. So steric inversion is very important to understand, right? Okay, now, so let's put it to the graph so we can see the potential energy and the coordination. This is the reaction coordinates. This is the potential energy up, the y-axis, and the x-axis coordinates. So there is reactants and there is products. It could be endothermic, exothermic. Don't worry too much about it. But the reactions goes to the product in one step. It's a simple hump, right? So it's one step, little hump. The hilltop monster, the transition state is on the hilltop. Remember that way, it's not real. So in the previous one I mentioned, carbocation is living in a valley, it is real. Transition state is hypothetical, right? And also one step and one hump, one bump, that's an important thing to understand, right? Now, so we also want to look at the rates, the reaction rates, how fast you can get products, or how many reactants you have to add, right? So let's finalize this umbrella flip thing. So if you start with the stereochemistry R reactant, your products will be S. If you start with S, your products will be R. So it's kind of like if you have the umbrella, let's say normally I put it the other way, that's fine. It just looks like the BR is the sticking point, and the umbrella stick, the handle is the BR. Now the handle is from the bottom iodine, so the umbrella would be like that. Because it hit from the back, it flips just like in the wind umbrella flips, right? It happens here in Vancouver most of the time, right? Because of the wind. So that's the umbrella flip. It's a good word and good way to look at the inversion of the stereochemistry from reaction to the product, right? Okay. Now, so this is the previous one that I mentioned. The carbocation is an intermediate, right? Okay, the rate. So the rate is depending on a rate constant. 2, you need to have lot of electrophiles and lot of nucleophiles. So electrophile, the substrate is E+, you need a lot of them, and you also need, because strong nucleophile, it takes part. There's 2 of them, so that is called the bimolecular. So when it is bimolecular, it's 2. Now you know, we break a bond, we make a bond, and 2 participating, it should be need 2, it should be bimolecular. If it is need 2, marriage is 1, and that's 1, it's 1 step. That's kind of the way I look at it. And my students, most of the time sitting in classes, they really understand this way, right? Okay, so it's 1 step. Now we can put a name, right? So this has to be SN2, right? Nucleophilic substitution 2. So that's the name for this reaction. So we previously finished 1, now we finished SN2. So now we can look at side by side, how do we sort it out? I will put some more practice questions on it, but let's sort it out side by side. It is like a decision tree, SN1 versus SN2. So how we separate, if you're given a reaction, your prof is asking, is it a SN1 or is it SN2? And there are 2 answers, you're going to have to figure it out, right? Let's see what's the order, what's the decision tree looks like. Okay, right. Now, let's put the SN2 name for the one I started without the name. Nucleophilic substitution. 2 means bimolecular. Bi means, okay, this is actually wrong. 2 steps. It's actually 1 step. No mistake, right? Okay, 1 step. And 2 pieces, 1 step. Or 2 people, 1 marriage, right? Okay. Let's go to the yes, the comparison side by side, the decision tree. SN1, so and SN2, right? So we're going to start with, let's look at the character, what we are looking at. The first thing to look at, the carbon attached to the leaving group, which is we call the electrophile. Sometimes we call substrate in biochemistry, right? So that one has to be tertiary for the SN1 compared to primary. Secondary is sitting on the fence, and primary is the best, and tertiary is the worst for SN2. So you see the comparison, that's how you want to see. SN1 tertiary the best, SN2 primary the best, and secondary is sitting on the fence, right? Best, worst, best, worst, and on the fence, right? Okay, so try to memorize it that way, and let's see the next one. Now when you're sitting in